Okay, hello BC Calculus students. Looks like we're ready to go with today's notes. This will be the last notes for the week. And this is trig substitution. We're getting ready to wrap this up. We've got today, we do have at least one more day with trig substitution next week, and then we'll start getting ready for the final, which essentially you should already be ready for since you've already been preparing for an AP test. But let's take a look at some more examples at a few different situations that are likely to come up and be aware of what's going on. So let's look at the first problem, our first example. Let's go ahead and let's integrate 1 over x squared times the square root of 4 plus x squared. So once again, we see this as the square root 4 plus x squared. So that's of the form where we're going to want to use, where we're going to want to make this the hypotenuse here. So let's set up our triangle. And so we see that we've got the hypotenuse. We have x here for the opposite side and 2 here for the adjacent side. And then we can go ahead. We know that we're going to want to use this over the constant. So we know that that would be secant. So the secant of theta would be this over 2. So 2 times the secant of theta would be equal to that. So we have that's equal to 2 secant theta. And then to find x, we know, set up a tangent ratio here. The tangent of theta is x over 2, so x is 2 tangent theta. And find dx by taking the derivative of the 2 tangent theta and get 2 secant squared theta d theta. Now we can go ahead and actually substitute in. So we have the integral of, notice our numerator is going to be 2 secant squared d theta, just our dx. That's the only thing that's in the numerator. And our denominator is going to be, when we square x, we get 4 tangent squared theta. And then when we put in for our radical expression, we get 2 secant theta. So right away, I see that I've got a secant that cancels with a secant. And I'll factor that 4 out. Whoops. I said I would factor that. Yes, factor the 4 out. The 2's cancel. And so it is a 4 that factors out. So I have the 1/4 in front. And notice I've got 1 secant in the numerator and a tangent squared in the denominator. Now, of course, this I want to simplify as much as I can. So if I look at that, that's 1/4. Remember, secant is 1 over cosine times, since I'm dividing by tangent, it would be multiplying by its reciprocal. So it's multiplying by cosine squared over sine squared. So canceling the cosines where I can, I get an expression of 1/4 cosine theta over sine squared theta. The good news is, this one, I don't have to do any special reduction formulas or any big manipulations. I can go straight to u substitution. If I let my u be the sine of theta, then my du becomes the cosine of theta d theta, which is right there. So it looks like I've got 1/4 times du over u squared. Integrating that, I would get a negative 1/4 u to the negative 1 plus a constant. And all that does is put the u down in the denominator. So substituting back in for u, I would get negative 1. I accidentally lost my 4 somehow. How that happened, I'm not exactly sure, but there should be a 4 here. And so carrying over, and when I go to do sine of theta, that's this over this, but it's the reciprocal of sine. It's 1 over sine, so if I put that up in the numerator, this 4 does stay in the denominator. Somehow I lost that 4 there, and that is the answer that I get. All right, let's look at another one. So now let's look at the integral of 1 over x times the square root of 9x squared minus 4. So going ahead and setting up my triangle. Notice, since this is 9x squared minus 4, this square root of this has to be the hypotenuse. So that's the 3x. There's my 2. So square root of that for my adjacent side, and then my opposite there is my radical expression. So going ahead, solving for this, the easiest thing to do that would be tangent. The tangent of theta is this over 2, so that radical expression is equal to 2 tangent theta. And then I know that when I go ahead and solve for x here, I know that the secant of theta would be 3x over 2. So that means that since the secant of theta is 3x over 2, solving for x, multiplying both sides by 2/3, x is 2/3 secant of theta. Finding my dx, take the derivative, I get 2/3 secant theta tangent theta d theta. Now I can substitute in. Substituting in, we get this. Oh, but wait a second, look at that. 2/3 cancel, secants cancel, tangents cancel, everything cancels except for a 1/2. So that's just going to be 1/2, and then times the integral, just the integral of 1/2, which is just 1/2 theta plus a constant. Well, theta, if I go solve theta here, I know that if I look here, secant of theta was this, so the inverse secant, so theta is the inverse secant of 3x over 2 plus a constant. Oh, look at that. We could have noticed, by the way, I did pick this intentionally, but I don't know whether you noticed this or not, but this is actually the form of our derivative for the inverse secant. All we would have to do is get a 1 here, which means we would have to factor out a 4 out of this, essentially factor out, and then if we did that, we would get that square root of 4, which becomes the 2. That's where our 1/2 comes from. And then as we factored that, that would become 9 over 4, which when we square that whole thing, it would become 3x over 2 squared. And so that's where we get this. So we could have done it as a simple u substitution with just a little bit of manipulation here. Probably would have been easier to do it that way, but it's not wrong to do it trig sub. But just reminding you, make sure you look first off. You may get something where this is not something you can do using u substitution directly, but it is something you can do with u substitution if you recognize it's in the form of the inverse secant. And that's what we get for an antiderivative of just the inverse secant. All right. Now let's look at one that we definitely cannot do that way, because we've flipped the order of these here, and this is not the form of the inverse secant. So we are going to have to go ahead and use trig substitution. So let's set up our triangle. So here's our triangle. Notice 4, it's 4 minus this, so 2 has to be our hypotenuse. And then we will put our 3x, and it really doesn't matter which order you do these in. You can do it either way. In fact, when I was practicing to make sure, because this is examples I came up with, when I was practicing, I actually had them in reverse order and did it the reverse direction, and it worked fine. But this way we get to work with not co-functions, but regular functions. So, looking at this, we know this is going to be that the sine of theta is equal to this over 2. So that here is just equal to 2 sine theta. For x, we know here that the cosine of theta is 3x over 2. So we know x is 2/3 cosine theta, which makes our dx negative 2/3 sine theta d theta. So from that, now we can substitute in. So our numerator is going to be that negative 2/3 sine theta d theta. And our denominator is going to be the 2/3 cosine theta times the 2 sine of theta. Notice the 2/3 cancel. I can factor out the negative and the 2, so I'll get a negative 1/2 in front. And that'll be the integral, the sines cancel, of just 1 over cosine, which is secant. Now here you can definitely save yourself a lot of time if you remember what the antiderivative for secant is. I worked this once before, but I'll do it again so you can see it in action. But if you have to remember to multiply by secant theta plus tangent theta over secant theta plus tangent theta. That gets us this. That lets us select this for u, which makes this du. So we can see that there. If you need to pause and write it down, you can. Some of you may have it memorized already, and so I'm moving through it pretty quickly. So from this, we simply get, this becomes du over u. So integrating that, we get our, should be a negative in front of there. Somehow that negative dropped. We get negative 1/2 natural log of u plus a constant. And then if I substitute back in for u, I get negative 1/2 natural log of secant theta plus tangent theta plus c. Now I can go back to my triangle to substitute in for secant of theta. Secant of theta is 2 over 3x. Plus tangent is going to be the square root over the 3x. And I could leave it like that. That is a valid answer. But if I want to, I could go ahead and I could take my common denominator there and write it like that. Or I could even recognize this half, bring it up here, and flip this and call it 3x over and the 2 plus the square root of 4 minus 9x squared, and not make it negative. That would also work. So there's a lot of different ways you could express that final answer. Okay, with that, go ahead, do this 28 through 38. I think there's probably at least 4 problems that you can do, maybe even more, maybe even 5 of them you can do directly with u substitution, and you don't even have to do trig substitution. But there are about half of them you do have to do trig sub, and that's what you really need a lot of practice on to get used to it. So go ahead, have at those, and hope you have a good weekend.